Good afternoon. On behalf of Engineers Australia, I'm delighted to welcome you all to our Thought Leaders series, Fast and Simple Bridge Modelling Analysis Design. My name is Amanda and I'll be your host for today. Firstly, in keeping with our custom, Engineers Australia acknowledges the traditional custodians of the country throughout Australia and recognises their continuing community. We pay our respects to them, their cultures, and to elders past and present. Before we get started, I'd like to acknowledge that today's webinar is being hosted with Engineers Australia industry partner Midas IT. The world is changing rapidly with new technologies, and Australia's infrastructure industry is. But how are we keeping up with the pace of change? Discover the easiest and most efficient procedures using Midas software featuring optimised modelling, analysis and design processes tailored for Australian engineers. Throughout this event, you can explore Midas IT's latest digital solutions released, Midas Civil NX. I'd like to welcome you to view a short video. Thank you.
If I was to describe Midas in one word, it would be efficient.
So Midas is very user-friendly actually too.
Midas is powerful.
Midas is efficiency.
Midas is tailor-made for bridge engineers.
Midas, in my opinion, is really interesting, first of all, and automotive at the same time.
Midas in one sentence. Practical.
I guess it really streamlines a lot of your processes. In most cases, in your post-analysis, it's very fast and efficient compared to using other software.
To use Midas as a graduate structural engineer, it has really helped me with my modeling and design skills. Learning so much from Midas, and I believe this is a very essential software for all structural and civil engineers to learn.
Software's ability to streamline design processes and analysis is of great.
It has all the tools needed for us to efficiently model our structures and achieve the results that we need.
Allows a structural engineer or any user to have advanced capabilities to be able to use that software faster and more efficiently to get the project work done in that sense.
In my experience, Midas has been super helpful since compared to other softwares and applications, the user is more user-friendly. The user interface is designed in a way that you can incorporate all the actions that you can possibly need with one simple clicks.
Today, we will hear from 4 speakers, followed by our audience Q&A, and I encourage you to send questions through to our speakers via the YouTube chat box. I'd now like to welcome our first speaker, Ken O'Neill. Ken is a passionate designer who thrives on developing clever, innovative solutions on the most challenging projects. Ken has 25 years of experience in delivering major infrastructure projects, specialising in bridge engineering. After spending 2 years working in Ireland following his graduation, Ken joined Oricon in 2002 and now is in the role of design director. He's a chartered professional engineer, a fellow of Engineers Australia, and the current chairperson of the Civil and Structural branch at Engineers Australia's Sydney division. Known for his expertise in bridges, Ken has presented at several national and international conferences on bridge design and regularly shares his insights and pictures of bridges on Instagram at BridgeCon. Please welcome Ken O'Neill.
Welcome to the Thought Leader series, Fast and Simple Bridge Modelling, Analysis and Design. My name is Ken O'Neill I'm a design director at Oricon. Also the 2024 chairperson of Engineers Australia Sydney Division Civil and Structural Branch. And I'm here to talk about current bridge engineering trends in Australia. So in Australia we have typical bridge types. Some are more common than others. So starting in the top left, we've got the pre-stressed concrete planks. These bridges are good for up to 21 meters. Then we go on to the super Ts, which have really dominated the Australian bridge landscape over the last 30 years. And they range between 21 meters and 37 meters. Although in Western Australia, they've expanded those and stretched out the spans quite a bit. Then we go on to UMAX girders. They tend to span up to 50 meters. And then we go into match-cast segmental bridges, which we've seen much more of in the last 15 years in Australia. And then where we need to get over particular constraints, we've got steel trough girders, incrementally launched bridges, and then we get into the more complex bridges, which again we're seeing more of in recent years, such as arch bridges, network arch bridges, helical trusses. There are many more types. What we're also seeing is a huge difference in the project size. So when I came to Australia in 2002, projects were very small in comparison to today. So what you can see on the screen here is a trend of project pipeline or upcoming projects from 2006 to 2025. So we're in 2024. You can see the massive increase in work and projects that are happening. So each color represents a different project and the value associated with that project. So you can see that there is a significant change in the size of projects that are happening in Australia, I would say around the world. Most recently, the South Australian government awarded a $15 billion project, which is one of the biggest projects that's ever been awarded in Australia. And that was only in August this year. Intuitively, you would think more bridge failures could have happened in the past. This is data extracted from Wikipedia, which shows the opposite. There's a definite spike over the past 20 years, despite all the analysis software and modern construction methods we have available to us today. Perhaps we are better at reporting failures these days, but there is no doubt there is a trend. Perhaps the skill levels are diluting with the projects getting larger and larger. Perhaps the maintenance budgets are not sufficient to keep our aging infrastructure safe and resilient. Perhaps we're experiencing more extreme weather. There is no doubt weather patterns are changing. In Australia, we're seeing the average temperatures going up, more extreme bushfires, heavier rainfall patterns that are significantly affecting communities and the economy. The graph shows the cumulative rainfall from 2022, which is trending well over average expected. This intense rainfall is having devastating impacts on communities. With intense rainfall, we get scouring of the riverbed under the bridge piers, or debris hitting into our bridge piers and damaging the bridge. You can see in the top left, there are some studies from the United States from 1989 to 2000, where hydraulic related failures have been the dominant failure mode of their bridge stock. In China from 2009 to 2019, you can see again that hydraulic failures are a significant chunk of the failures of bridges. Interestingly, the construction-related failures, during construction-related failures in China is number one in that reporting period. So you can see some bridge failures here. Malahide Viaduct in Dublin was a rail bridge where a pier scarred out in the middle of the night. Luckily, the train saw it and nobody was injured. And only earlier this month, we've seen a bridge collapse in Vietnam where 64 people have died as a result of a significant typhoon and floods that swept away a bridge. So talking about sustainability in the circular economy, we can see here the embodied energy of different materials. So you can see there's some materials are very intensive in terms of their CO2 emissions to produce them. So if you look at a bridge like the Richmond Bridge in Tasmania, which is about 200 years old, you can see it's got low embodied energy because it's made of stone. It's locally sourced materials, low maintenance, and long life. And I wonder if the designer thought about those things in the early 1800s when they were designing this bridge. Now we'll talk about the circular design principles, which focus on three main areas: smarter product use and manufacture, extend lifespan of product and its parts, and the useful application of materials at the end of life. There are 9 R's that I won't go into now, but this is all about making the most of the materials that we've got and maximizing their life and their use. So if we look at the bridge in Tasmania, whether the designer knew it or not, they were using locally sourced materials and kept the bridge in good condition by repairing and refurbishing it. They've extended the life significantly, and now it's a tourist attraction that draws people to the local town. So it's got an economic value to the town as well. So in summary, our designs are designed to a 100-year design life in accordance with our bridge design code AS5100. So I ask, is this enough? If we could extend the life of our bridges, we can lock in the embodied energy or CO2 used to manufacture them for longer, which is a significant benefit to the environment. We should be making these materials work for us for longer. Eventually, the materials that we use today will run out. So how do we do this? We need to innovate. We need to use less materials. We need to look at alternative materials to the conventional steel and concrete that we use. We need to use the powerful design software that we have at hand to keep our existing bridges going for longer and push the boundaries of design. We need to collaborate with our transport agencies and contracting partners to provide more sustainable outcomes. I hope you enjoy and are inspired by the upcoming presentations by some wonderful speakers today. Thank you.
Thank you, Ken, for a great presentation. I'd now like to welcome our second speaker, Jennifer Anaton. Jennifer is a technical director at Arcadis and has over 20 years of experience in bridge design in Australia. Jennifer carried out independent verification for road, rail and pedestrian bridges for many projects to ensure that analysis, design and drawings comply with the Australian standards, project specification, VIC roads, MTM and V-line requirements. Jennifer has carried out tender designs for major projects, including Westgate projects and many level crossing, and completed many detailed design and proof engineering for various bridges, verified assessment and strengthening of existing bridges for several projects. Please welcome Jennifer Anaton.
Hi, I'm Jennifer Anaton, Technical Director at Arcadis, and today I'm going to talk about continuous super T-beam design and construction stage modeling in Midas. Why super T-beams are used as continuous at supports, why construction stage analysis is required, and how to use Midas for construction staging, how to input in Midas for tendons, prestress, creep, and shrinkage, how to check results at each construction stage. This is what I'm going to discuss in this presentation. Super T-beams are widely used in Australia for economical design and construction, mainly because beams are made precast and prestressed at factories for better concrete finish. Beams are installed directly on bearings at site, and deck is cast on beam top without any formwork, so faster and safer construction over traffic. Beam flanges can be easily made as curved or skewed to suit the deck. Why super T beams are designed as continuous? With available beam sizes in the market, maximum span that can be achieved as 35 meter, and the maximum beam depth of 18-15 are typically cast in the precast yard with the available formwork. Beam length is limited for the transport to site from the yard, and clearance below the bridge requires shallow beam at some locations. Most strands can be used, but which will need higher concrete grade at transfer and at ultimate limit stage. Maximum number of girders also limited, as minimum top flange width can only be 1250 as shown below. What are the advantages of continuous super T beams? Due to continuous span, the reduced sagging moment happens, so the girder depth can be reduced due to reduced sagging moment, or the span length can be increased by using the standard super T beam due to continuity, and the midspan deflection will be reduced due to continuity at support. And since there is only single bearing, there is a cost saving, and when the beam is integral with crosshead, there is no bearings required at all. An example is shown here. Continuous beam is supported on single bearing at pier, which is used for 39 meter span. And another example is shown here. Continuous beam is integral with pier to reduce the beam depth to satisfy the low clearance below. Sometimes we need post tension at top for the larger spans, because we normally use 200-250 thick deck concrete, which is not sufficient to provide too many reinforcement for the hugging region, or it will be too congested in the deck casting. Why Midas is used for construction stage analysis? Secondary effect due to continuous beam is very important. Long-term effects in composite actions are also important for continuous beam. Load combination at every stage is important because property changes from pre-composite to post-composite. Boundary changes as simply support to continuous beam, so this will affect the design actions. Load changes from due to pre-stress losses from transfer to 30 years. Why Midas for construction stage analysis? Because it has automated input within the software. For an example, you can create composite super T girders for construction stage. ES5100 super T sections are available in section property. ES5100 concrete data such as compressive strength, creep, and shrinkage as time-dependent data. And it's easy to input tenant profile and pre-stress load, so easy to check the beam hog and stress at every stage. as well as differential temperature is given as AS5100 for hot and cold top effect. It can be easily input from within Midas software. As for any other bridge, 3D gauge model with beam elements can be used, but section offset to be aligned as center of section as shown here for easy input for tandem profile from soffit. Composite PSC section to be used for super Ds, elastic links to be for bearings, and rigid links to be for integral connection to be used. Temporary supports are important for the super T supports. I'll explain later how to activate sulfate blisters, deck core stages for construction stage modeling. Important thing for construction stage model is grouping for activation of each stage. First of all, structure group is to be created for substructure, super D beams, pier diaphragm, or the elements for deck core stages 1, 2, 3, etc., transverse beams, etc. Then the boundary groups to be added, which are required for different stages. For an example, as shown below, temporary support for beam for priestess or at installation, bearings at abutment or pier, or rigid link when integral at pier crosshead, as well as beam and release at link slab or expansion joints. Then load groups are to be defined for each stage, such as self-weight of substructure and super T beams, priestess in beams at transfer, deck point stages, whether it is midspan or near support is cast best, the design action will be different. Finally, the post tension at top is required in the beam. It should be noted more input is required for construction stage modeling because section changes from pre-composite to post-composite, which will have different stiffnesses. You can see an example here how to add composite section for construction staging from the menu, and composite stage, age at activation, hypothetical thickness are important in the input. Another one, at ultimate limit stage, only 20% of torsion consent to be considered, but it can be added in stiffness scale using the boundary group as shown in this screen. To activate composite section, first you need to create composite PSC. So you need to add super T section as PSC value from PSC section using database as Australian Standard Code, and you can select any T1, T2, T3, T4 as you wanted based on the super T depth. But you can change the super T top plunge width or soffit thickness by using define by coordinates and changing the XY inputs. To create composite PSC, you have to select composite section and then input deck width and depth. Select A17 concrete for slab and beam grade. That will automatically calculate the composite section property. But you have to enter 0 for density ratio as deck weight will be added as beam load. Time dependent compressive strength can be easily added using the menu as shown here. First, check the days for FCT at transfer, which will be required to activate the beam for priestess in construction staging later. Time-dependent clip and shrinkage can be easily added using the menu as shown here, but using AS5100 code has to be selected. But the results need to be checked against AS5100 table, and you need to check whether time at loading for clip and shrinkage is input correct, because this will affect the clip and shrinkage results later. The next important thing is to link all the material properties for which creep and shrinkage effects are to be considered. You can see the menu here how to link the material. Concrete material can be easily selected using AS17. When C40 is used, all data will be populated as per AS50 100. But for dummy members and transverse deck members, density needs to be modified as 0. And for super T beams, density to be modified as 26.5. To add tendons, first we need to define tendon property as shown here. Select TEM pre-stress under load menu and click on tendon property. Then add internal pretension for pre-stress and input all data as per the design as shown in this slide. But for post-tension tendons, more information are required as shown in here to estimate the losses correctly. When you select post-tension, you have to give duct size, friction factor, slip, etc. In order to add tendon profile for a beam, first you have to select the beam element where you are going to add that tendon, then input number of strands or debonded length as shown in the slide, and also provide the eccentricity from the soffit of the beam and show where you are going to insert as a start of the tendon shown here. Once a tendon profile is created, it's easy to key or move from one beam to other beams, and number of strands or debonded length can be easily changed using MCT file, which is very efficient. Pre-stress can be added using tendon pre-stress menu as shown here, or using the table. Pre-stress can be applied as force or stresses. Pre-stress in super D beams are usually applied at both ends. Post-tension can be applied from any ends as you actually design. The next important stage, we have to define the construction staging for analysis. So this is an example is shown here. You select construction stage and define construction stage, and you start adding different stages such as substructures, super D for pre-stressing, deck casting for stage 1, stage 2, etc. Or when the pier diaphragm is composite, you have to make it active, and finally the whole bridge is active and the super T beams are composite. This is an example how to create the construction staging for substructures. Create a name and add duration and activate the load sulfate only, and activate the substructure with 28-day strength. Activate the supports for the substructures. The next stage, what I have considered super T at pre-stress transfer. This again is duration depends on beam installation day, usually 30 or 60 days. Then activate super T, which was already defined as composite section for construction staging. Activate pre-stress only because sulfate was already activated in the previous stage. Activate the temporary support at beam ends. But it is important to check at this stage, super T only is activated and there's no deck included. This is an example how this stage is activated. As you can see, the duration is provided. As I mentioned earlier, activation date for pre-stress is important based on assumed FC at transfer. It is important to check supports and pre-stresses are applied correctly at this stage before analyzing. The next stage I have considered beam is installed at site. So first deactivate the temporary supported beam ends, but activate the elastic link for bearing at abutment, as well as activate the temporary support near the pier end. And it is important to check the results at this stage, and I'll show that later. Once the pier diaphragm is achieved, 28 days 10, pier diaphragm, including the length of the Super T already made composite with deck, to be activated, but deactivate the temporary support near the pier, but activate the elastic link if it is a bearing, or activate the rigid link if it is integral with the pier, as shown. The example shows here how the stage was activated. You can see all the pier diaphragm is activated at the age of 28, and temporary supported pier is deactivated, and pier link is activated here. The next stage is the rest of the deck is cast. So you have to activate the loads only for that stage, and you have to check if it is applied correctly. Finally, you have to make all the members active, and all Super T beams are composite, but you have to apply duration of 30 years to consider long-term creep and shrinkage effect. You can use construction stage analysis control to separate load cases for construction stages, as shown here. For an example, when you separate self-weight and deck, you can easily check your hand calculation and the model results are same. This is the final load that I told you how to input differential temperature effect. You select beam section temperature and select PSD composite and apply code provision as per AS5100, then everything is automatically populated. Then you can check the secondary stresses. Model checking is important before combining loads. So this is one of the examples. During pre-stress at transfer, no support is at abutment, so there shouldn't be any hugging due to sulfate. You can check first. Another one, when the beam is installed and bearing at abutment, there should be hugging moment due to sulfate, that you can check it from the model results. Once the beams are made continuous at pier, there should be hugging moment at pier for sulfate of beam, that you need to check whether it is right. Some other results can be checked from Midas against your calculation Autodesk output. This is one of the things that I want to show. Based on the pre-stress input and the section property, Midas can calculate the beam hug at transfer or at any stages. So you have to go to that particular stage and check what is the beam hug compared to your results, as well as you can check what is the pre-stress moment in the beam at transfer or at any other stage compared to your results is correct. This is also important to check what is the beam hug once the beam is composite, because that has a different stiffness and different pre-stress, because there will be some pre-stress loss at that time beam is made composite. This is another advantage in Midas, that you can check the beam top stress at transfer or at any stage by selecting the menu as shown here to see whether that is within the limit, also to check against your results before combining any load. Similar to that, you can check the bottom stresses at transfer or at any stage. That will give you the limiting stresses are adequate, so you can modify the design. So in conclusion, continuous Super T beam design has many advantages, such as longer span can be used using the standard Super T beam sizes. Shallow beam or less number of strands can be used using the continuous beam. So it is an economical design and construction. Midas is easy for construction stage modeling to include pre-composite to composite section changes, boundary condition changes, as well as for pre-stress changes. Secondary effect due to beam continuity and support can be easily included. Tape and shrinkage, hot or cold top effects as per AS 5100 2017 is already included. Easy input for tendon, pre-stress, and post-tensioning in Midas. The final easy thing that you can check the beam hog or stress set transband at every stage against your calculation to make sure they are right. Thanks for listening to the presentation. Thank you.
And now I'd like to welcome our third and fourth speakers, Young Park and Pranav Vaishampien, who will be presenting together. Young is a civil engineer technologist who graduated from Cambrian College in Canada with over 2 years at DCAST, specialising in pre-stressing girders, concrete testing and quality assurance, ensuring compliance with industry standards. Currently, Young works as an account manager at Midas IT, leveraging their technical expertise to manage client relationships and drive infrastructure projects. Young strongly focused on quality control and process improvement in his role in the civil engineering field. Pranav is a structural engineer who brings expertise in structural dynamics and a wealth of experience in building projects. He has proven his proficiency at Midas and has been providing technical support, training and solutions to clients for products like Midas Civil and Gen. Also, Pranav has conducted training sessions in Australia on the analysis and design of Super T girder bridges, focusing on moving loads and construction stage analysis. Please welcome Young and Pranav.
Thank you, Amanda. Good afternoon, everyone. This is Young Park, account manager for ANZ region. It is my pleasure to present to you Midas Civil NX. It's renovate software by Midas IT. The agenda for today is as follows. First, we'll discuss what our organization aims to achieve through the Midas Global, which benefits engineers worldwide. Next, we'll address the question, why Midas Civil NX, by exploring the key features of the software. Then my colleague Pranav will take over the presentation, discuss the key feature of the Civil NX, the API, and how it can be used, needs, and interests of engineers. Let's begin with part one, from vision to reality. Midas has a global network with 20 branches and over 1,000 employees. We serve more than 110 countries and have over 10,000 users. Our team is always ready to deal with any issues you may encounter, which is truly remarkable. But we don't stop here. We are consistently expanding our services and working to deliver even more value to our client worldwide. Midas solution has been applied to both historical structures and everyday structures that form an essential parts of our lives. We offer a variety of software solutions in the fields of civil and geotechnical engineering. And we are extremely grateful that engineers use our software to add value to the society. Here are some of the most remarkable structures built using Midas software. The tallest building Burj Khalifa in UAE, the artistic Beijing National Stadium in China, the well-known Northeast Link in Australia, the historic Duomo di Milano in Italy, the longest cable-stayed bridge Russky Island Bridge in Russia, lastly, the Incheon Bridge in Korea. We are committed to supporting civil engineers by providing many opportunities to learn and grow. Through our training session and meeting, we aim to create a community of skilled engineers who can help advance the field of engineering. With our hands-on experience in engineering design, we focus on practically and aim to develop products that meet engineers' needs. We are excited to share our new solution, Civil NX, along with our API service. In this brief demonstration, you'll see how to integrate Excel VBA with Midas Civil NX to automate a single cell box bridge using the API connection. So why Midas Civil NX? It offers essential simulation features for bridges and civil structure, including static analysis, construction stage analysis, moving load analysis, seismic analysis, and more. These features aren't just for bridges, but are useful for a wide range of civil structures in various projects. Civil NX has a brand new look and is much more user-friendly compared to the previous Midas Civil. It comes with major upgrades, including a completely redesigned user interface, 20 times faster post-processing performance, a unified file format, and user-focused features like in-app search functionality. Let's start with user interface for Civil NX. It features a sleek black color theme that aligns with the latest trends. The workspace is wider, allowing the command window to fold away. A slide bar in the bottom right corner lets you adjust node element font size and the size of transparent labels in real time. The search function in the tree menu helps you easily sort through the trees. We've provided the edge graphic resolution of the model. Vector icons have been added to work well with high-resolution monitors. Icons of the same category have been grouped together for user to identify easily. As mentioned earlier, we've added a search bar to the tree menu. This allows users to search for and view only the contents they need. Imagine working on a large bridge project with complex tree menu. This feature helps users quickly find what they're looking for. As you can see, when I search for something in the tree menu, it is instantly sorts the relevant data and shows only the appropriate model applications. In Civil NX, you can easily choose color for each category, which helps differentiate the elements. For example, the superstructure can be red, and the substructure can be blue, and so on. In Civil NX, transparency can be specified for each component, allowing users to adjust the transparency of individual parts. Additionally, an option has been added to visually present tendon, which was previously only displayed as a label. By setting the component to transparent, user can now visually confirm the presence of tendon, which within the component, and this would reduce engineers' error of missing some tendons in the components. Civil NX has improved its graphic to give user full control, making it easier and more comfortable to use the software. This is a short demonstration video. We'll show how to modify the font size to make modeling easier and more efficient. And now we want to increase the font size for load value. We can select the specific load from the tree menu and display it. If we want to adjust the transparency of section, we can select and particular elements. Furthermore, the design of the analysis window has been reinvented. It now provides a detailed view of the progress of each individual analysis. Our future development plan is to replace current Midas Civil Solver into MEC Solver as our Midas FEA NX. And this will allow users to select and analyze only the parts they want. We have kept this currently at the priority. The analysis results are displayed in the hidden form in the comment line at the bottom and pop up with message during analysis executions. Previously, users were struggling to find their error on the specified nodes or elements in the screen, but now clicking on the corresponding error message line will zoom the screen to the location of the error, allowing for quick identification of the nodes or elements with the errors. An internal search bar has been introduced in Midas Civil NX, which you can search anything related to Civil NX. Need information on a specific function, a tutorial, or a search FAQ? The search bar is the Civil NX is your go-to tool. As shown, you can access 4 types of information right here. Like here, we can see we searched the term BeamN, and we got the related tutorial of BeamN releases and the related FAQ. So we do not need to go outside of the software. We have everything as a built-in feature. Now we are moving on to strong suit of Civil NX. Midas Civil NX has a huge database for material properties as per the codal provisions of different regions throughout the globe. The configuration for different structured materials like concrete, steel, and more, commonly used in Australia, have been implemented in Midas Civil NX. As mentioned, here the material properties for elements and the tendon property both have the codal provisions. In addition to materials, various types of sections are available by country codes or in user-defined form around the world. As you can see in the short video, there are various PSC sections available to define. We just have to compare with existing GAD and choose the appropriate section. You can easily define section for steel, RC, PSC, composite, and tapered section and check the cross-sectional characteristic right away. As shown in the slide, Midas Civil NX offers a variety of sections that engineers can use. They can easily compare their general drawings with the graphical view here and interpret the value to enter accordingly. The SPC is now integrated into Civil NX. Previously, it was a separate tool, but now you can use it directly in Midas CAD with familiar commands and workflow. You can efficiently calculate and modify cross sections you need using tools within Civil NX. In the demo, we see a custom section that isn't standard shape the database. This is how we modify the cross section using CAD. This is fixed and can easily adjust the height function. With CAD, we can skip an extra step, importing the section directly into Civil NX. Midas Civil NX automatically generates analysis models for standard civil engineering structures commonly used in practical design, significantly reducing modeling time. Both 2D and 3D structures can be quickly created by simply inputting various variables. PSC segment bridge using ILM, MSS, FSM, and FCM methods, including construction stage with the design-focused modeling approach for faster project completion. This is an automatic modeling feature for PSC composite and steel composite bridge. For PSC composite bridge, it allows for easy placement for PSC tendons by type, simplifying complex tendon placement. You can also apply different concrete construction loads and model construction stage step by step. For steel composite bridge, you can input bridges detail from working drawings. We offer models for tubular bridges that are suitable for design and 3D modeling method. Conventional grillage model, girder as a beam and deck as a plate, and lastly, all plate model. Special bridges models with cables can also be easily created. By including the initial forces in cable stage and suspension bridge models, the work time can be significantly reduced. There are cases where special modeling is required. After completing a global system analysis, if a transverse analysis is needed, transverse model can be automatically created from the global system model. It also features an automatic function that converts wide PSC cross-sections into a grillage model, which helps account for transverse behavior. One of the most commonly used wizards offer automatic modeling for rail track analysis, considering rail track interactions, which is crucial for railroad bridges. By inputting different variables, you can create a model that can be reviewed in multiple ways. The result can be even exported, reviewed in Excel format. In Midas Civil NX, you can easily add temperature loads in various ways, such as beam section temperature, element temperature, and temperature gradient. For example, with beam section temperature, you enter the temperature differences at specific location on the beam for thermal stress analysis. When it comes to wind load, especially in superstructures with varying depth, you can use additional offset function. This function automatically assumes a user-defined height for the parapet, allowing you to apply an area load to simulate the wind effect. Midas Civil's moving load analysis provides a vehicle database for various country codes as per AS 5100, standard traffic vehicle, railroad, heavy load vehicle, and rating vehicle are directly incorporated in the software. And you can easily determine where vehicle loads will have the most critical design result. Additionally, a function is provided to optimize the lateral position of the lane for moving load analysis to obtain the most critical results. The function that Midas Civil NX can introduce most confidently is construction stage analysis. You can check the accumulated results through step-by-step simulation of structure. Construction stage analysis looks at how complex structures behaving during and after construction. It considers the time-dependent characteristic of materials. This characteristic includes creep and shrinkage, as well as compressive strength. You can analyze strain and compressive strength for creep and shrinkage based on different country codes, taking into account how these factors change over time. Among the results of construction stage analysis, Midas Civil NX offers a camber result table and graph. These tools can be used on site to help ensure efficient constructions. This slide gives an overview of the software's capabilities for PSC section. You can simulate both regular and tapered PSC section, and it automatically arranges rebar. You can define tendon profile by coordinates, use tendon templates, or import them from CAD. The software also allows you to check beam stress output at up to 10 locations. Finally, there is a dedicated tab for PSC design that supports various design standards including AS, ASHITO, and European codes. Everything you need for PSC section is provided. The previous slide talked about tendon definition, and this slide highlights the type of tendon you can define. You can work with post-tension tendons, which include both internal and external type, as well as pre-tension tendon. The design of PSC section can be done using either of these tendon types. Next, we will introduce 3 nonlinear analysis tools for areas with frequent earthquakes. First is pushover analysis, which is nonlinear static analysis method. This function allows you to evaluate the structure by comparing its resistance capacity to the required seismic response after yielding. It takes into account the nonlinear characteristic of the material in the structure. The second tool is dynamic boundary nonlinear analysis, which applies a nonlinear device to the connections in the structure. This analysis is useful for examining the nonlinearity of foundation separation device and seismic isolation devices. It provides detailed insight for analyzing bridge structures. The third tool is analytic time history analysis, which is considered the most advanced method for seismic analysis. This analysis predicts the inelastic behavior of structural members and determines the seismic response of the structure using hysteresis model. The model simplifies the nonlinear characteristic of the structure members. Inelastic time history analysis supports fiber model that can consider various nonlinear material model of column cross sections. Precise seismic performance and safety evaluation can be analyzed. Midas Civil NX design capabilities support highly reliable design process used in more than 120 countries around the world. You can proceed with design by intuitive selecting product features. As you can see, we provide various design codes for RC, steel, SRC, composite, and PSC design. PSC design in Civil NX can be done by accessing the bending, shear, and torsion design featured for the PSC database and general section. This process considers various design variables specific to PSC. Additionally, PSC composite design is also capable of bending, shear, and torsion design for composite PSC, database, and general section. For composite section, we provide review for bending, shear, and constructability, considering different design variable and conditions. After you run the design for your structure, you can create an Excel report with all the details. This report also includes the code clause used in each design check. This saves you time and lets you quickly find the information you need instead of searching through long code documents. We'll have to look at some of well-known projects application in which Midas Civil use in Australia. Many global design companies trust Midas software. Here are some of the firms that have relied on Midas software for several major projects. The Caulfield of Dandenong level crossing removal project has done by Midas Civil. An ultra-highway performed pre-stressed concrete integral bridge. And the Warringah Freeway Upgrade Project. And the well-known Northeast Link Project is also done by Midas Civil. Civil NX will bring great changes to civil engineering practitioners and also is paving a way for future advancement in the software field of civil engineering. Thank you. Now I request my colleague Pranav to take over and continue further.
So, thank you, Yang, and hello everyone. My name is Pranav, and I work as a bridge engineer at Midas City, Australia. Without further ado, and to keep the momentum going, let's dive right into the highlights of Civil NX, our flagship solution for civil engineering. I'll be covering part 3 of the Civil NX product launch, which will include the API capabilities of Civil NX. So firstly, what is API? API stands for Application Programming Interface, and it allows us to transfer data from one software to another without directly accessing the software. Let us understand this with a real world example. Websites like booking.com or Skyscanner allows us to book hotels and flights through a single portal without directly accessing the individual hotel or airline websites. This is made possible through API. APIs provide a backdoor to access specific features of a software. In our case, Midas Civil NX can be accessed through external software, allowing seamless integration. Since each software uses a specific programming language like VBA, Python, Java, C, C++, and many more, it is necessary to have a unified format for seamless data exchange. And this unified data format is called JSON. If I have to simplify it by giving an example, let's say we have a code written in Python. We will first convert it to a JSON format and send it to Midas Civil. Midas Civil reads this JSON file, executes the code, and returns the desired output. The same process applies in reverse. That is, when we request an output from Midas Civil, it exports the data in JSON format, which can then be converted into a desired format by the users. We also have a short course on API on our Midas Academy website. So for those who want to know more about API and how does it work, please check it out. Now, this slide highlights a few possibilities of API with external software commonly used in civil engineering. By leveraging API functionalities, we can integrate Civil NX with various external softwares, enhancing workflows and automating tasks. In the upcoming slides, we will explore how these API capabilities work with some of the key external softwares used in daily work in a civil engineering. A key point to note here is that Civil NX API is not limited to software shown on the screen or the ones we'll see in the upcoming slides, but it can be connected to any software capable of converting its respective coding language into a JSON format. This includes tools such as MATLAB. Now, let's start with the most easy functionality which every engineer can use. So most structural engineers are not familiar with coding. So even though API is powerful, it may seem difficult to use because it requires programming knowledge. For such instances, the Midas Excel add-in provides a user-friendly alternative. This is an Excel add-in that enables data transmission to and from Midas Civil NX without the need for coding. In my experience, many users desire design automation. Typically, after conducting an analysis, engineers use their own Excel templates to perform detailed design based on the analysis results. Almost every individual rely on these Excel templates as it gives the engineer a sense of control and design over the design calculations. In such cases, the Excel add-in known as Midas connector can be seamlessly integrated into the existing workflow, enhancing the engineer's efficiency. With help of this Excel connector, you can set up a template for your company for the first time, and for the future projects, with just a few clicks, you can extract results in a go for all the result table and images. So in this example, which is shown on the screen, we will obtain results of reactions, reaction tables, and the images. So you heard it correct. Not only the result tables, but even the images can be extracted from Midas Civil. So once we save the table, we'll select a cell where we want to import the result, and we'll click on import all result table. So we can see the reaction table is imported. We can cross verify the values. These are matching with the software. Next, we will import the image. So we go to result image, again select a cell where we want to import the result image and assign it to a certain folder and click on import. So this is a single import function for tables and images, but we can import hundreds or multiple images of result tables and images simultaneously with a single click. Okay. Now, for those engineers who are proficient with VBA, I would like to introduce you the process of modeling and designing by integrating Midas Civil NX with Excel VBA using APIs. So when designers use Excel for design, it is common for them to perform structure analysis in Civil and then copy and paste the analysis results into Excel. They utilize the Excel formulas to facilitate the design process. In this process, the structural analysis model is automatically generated in Civil using the specifications entered in the Excel. This includes information such as loads, boundary conditions, construction stages, tendons, and many more, which can be directly input into the model through the Excel formulas. As a result, modifying specific specifications in Excel allows for immediate updates in the Civil model. So as we can see on the screen, there is a 6-span continuous PSC composite bridge, and it includes all the loads, boundary conditions, and even the construction stages. So we saw without even clicking a single button in Civil NX, the entire model was generated through the API connection. Similarly, an analysis button was developed in Civil. So we click the analysis in Excel and the analysis is carried out. So after the analysis, we'll also go to the results extraction part. So there is a separate tab generated in Excel, the data result. So we go to data result, and again a button is created called as get result table. When we click that button, result table will be imported. So as I mentioned, multiple result table, maybe it of stresses, bending moments, everything can be imported with a single click. Now images, so various images of bending stages at each interval can be extracted from the software via this VBA connection. Now coming on to the Python compatibility. So many engineers are now compatible with Python, especially due to the recent boom in the AI and machine learning domains. These topics are increasingly being encouraged in the universities and are commonly chosen for research and master thesis projects. In light of these trends, I will now provide a short demo on integrating Python with Civil NX. This demonstration will showcase how engineers can use Python scripts to automate tasks, streamline workflows, and enhance the design processes within Midas Civil NX. The example video demonstrates how Python can be used to optimize the size of a steel section. So by running analysis with Python, the script automatically performs multiple iterations to determine the best section case for the given condition. Like this, we can write your own code for specific structures and check and optimize. So we see the difference between first iteration and 8th iteration. The structure weight is being optimized with each iterations. Now, parametric modeling, which is possible through Rhino Grasshopper integration with Civil NX. Many engineers now focus on parametric modeling, which is beneficial for those who keep on designing similar structures with minor changes in the alignment, in the geometry, or some other parameter. Traditional structural analysis software can be cumbersome for simple modifications which require extensive work. With Civil NX and Grasshopper, you can easily adjust the models anytime, quickly create similar ones for future projects too. The Midas Grasshopper plugin includes nearly all Civil NX features, which allows you to apply load cases, conduct construction analysis, perform analysis, obtain results, all within a single Grasshopper file. So the structure of Midas Grasshopper is very similar to Civil NX. The same categories and the same themes, it is easy to find whatever you want. For example, in Civil NX, we use supports under boundary tab and set the boundary conditions. Similarly, in Grasshopper, we have a similar component of boundary category, which includes the support component in it. The video demonstrates the same. Now, this video will provide a brief demonstration on the powerful integration between Civil NX and Grasshopper. So you can see a Civil NX window to the left, right top we have Rhino, and right bottom we have Grasshopper. First, we copy and paste the URL and MAPI key from Civil to Grasshopper to create the API link. Then we will draw a simple arc in Rhino using its basic functions. The semicircular imaginary artistic structure is considered here on purpose to showcase the dynamic nature when it comes to modeling using Rhino Grasshopper. So with a single click, the nodes and the elements of this artistic structure are generated in Civil in real time. Now we will apply a UDL load manually in Civil. So just the regular procedure, we define certain load, click on apply. We can see, consider this as a deck element on which the UDL load is applied. We can adjust the offset, height, deck width with the slide bar created in Grasshopper. And once again, click on the node button. It will update the entire geometry in Civil. Now let's draw a new curve in Rhino, an S-shaped curve to test the parametric capability. And within seconds, the Civil geometry is updated to the new one. So first it is updated in Rhino, and we'll again play around with the offset and the height, and boom, the Civil NX geometry is also updated. Not only the geometry, but if you observe closely, the UDL load is also updated accordingly. So this is a very powerful integration when it comes to parametric modeling. About the tendons. Now there is a very specific reason wherein I have chosen this option to showcase with Civil NX and Grasshopper. In PSC bridges, especially with curved alignments, even a slight change in the alignment can turn into a tedious task of rearranging tendons. We need to change the coordinates, we need to change the XYZ locations and everything. With Midas Grasshopper, you can apply tendons in exact shape you need, and their configurations will automatically adjust as the bridge alignment and span changes. Additionally, the positions and the quantities of these tendons can be easily modified, making the process highly convenient. You can also represent the tendon pre-stress loads and other related factors seamlessly. Furthermore, if you create a Grasshopper template for frequently modeled structures, you can easily use it again for future projects, simplifying the modeling and the analysis stage. Here we are looking at a Grasshopper script of generating a network arch bridge. This script is being executed in 7 steps. So first we create time dependent material properties using this script. Second, we created sections and thickness for plate elements and beam sections. Third step, we created the entire model by creating nodes and elements. Fourth step, we have created supports, elastic links where required, and assign beam end releases to at respective locations. Then sixth step, we are creating the load cases and assigning the loads. We can see parapet loading or wet concrete load or just varying surface loads are being applied. And finally, create the response spectrum function and response spectrum load cases for the dynamic analysis. So all of this has been done using the Grasshopper template. Moving on to the Midas marketplace. So what is this? So this can be considered similar to Play Store or in Android or App Store in Apple devices, wherein we obtain a variety of apps. So Midas consistently adds new plugin to this marketplace. This is a option inside the software itself. So organizations can create their own plugins, upload them to the marketplace, retaining full rights to manage the access within the organization, or they can even share it with the entire Midas community. I'll walk you through a recent plugin that was uploaded to this marketplace last week. So I would like to introduce to you all the all new Midas Space Gas Importer plugin. There are many types of structure analysis software which are available in the industry which has its own strengths. While various tools are useful, Midas software stands out for its unique comprehensive analysis capabilities. It excels in analyzing medium to long span bridges, including pre-stress girders, box girders, composite structures, segmental and extradose bridges. Midas offers advanced modeling and simulation features, enabling precise simulation of construction stages, time-dependent effects, moving loads, and many more. This allows engineers to obtain detailed results, including critical design calculations, making this the powerful tool for complex structural analysis. Now, this video demonstrates the Space Gas Importer plugin. So, Space Gas has metric and imperial unit system. It supports both the unit systems. So the video is shown here. Then we go to file. We first save the Space Gas file in a txt file, Space Gas model in txt file. Then we go to Civil, activate the plugin, click on connect, and we invoke the space gas importer plugin. Here we'll see we'll import the extracted TXT file, and the model will be quickly converted into Civil NX model. As you can see in the video, in addition to the shape information, you can also see that the material, section, boundary conditions, and loads are converted all together. So we can see supports over here, beam end releases, and static loads. In fact, in case of a simple model, you can analyze the converted model right away and check the result as follows. So we go to results and check the reaction results. So we are checking the reaction results now, and then we check the deformations. Simultaneously, beam stresses and plate stresses, everything can be checked similarly. Also, another example of a completely converted model using the API plugin. Also, a detailed explanation of the space gas import function is well explained in the manual. So I would recommend checking it out. You can check the supported range of conversion methods, element types, materials, sections, boundary conditions, loads, etc. in the online manual. So this is just a go through of the online manual. Now on the screen, we can see a glimpse of extensive research and verifications conducted during the development of the plugin, using various follow-up models from the space gas and practical models provided by the local engineers. This is a step forward that Midas has undertaken to enhance the collaboration during working on projects. For detailed description of the plugin and its technical capabilities, please refer to the plugin manual available online on the Midas website. So many such useful plugins such as alignment generator, load combination breakdown, tendon profile converter were developed on user demand. The product feature may not always be convenient or optimized for every user. Some user may prefer a simpler modeling process during pre-processing, while others may prefer or they want to handle or verify data in specific ways during post-processing. So at Midas IT, we continuously conduct market research to develop plugins that benefit our customers. Our vision is to empower users to create the tools that they need for their specific workflows. Just like the Midas help manual and analysis manual, which provide a detailed explanation of every software function, we also offer a comprehensive API manual. This manual covers everything, like from the basic functions, examples to quick tips, JSON syntax, plugin information, which is designed to give you a complete understanding of API with Civil NX. We encourage every civil engineer to take the first step towards automation with Civil NX. Whether it's automating the creation of beams, supports, or tendon profile information, tendon optimization, we are always here to support you, assist you with the technical trainings and guidance throughout this journey. So let's start this journey together and connect more, create more, opening doors to software integration and expansion. Before I conclude my session, I would like to make an important announcement. So we are thrilled to present two new Midas design guides for ANZ region. First one is a PSC concrete girder bridge, like a box girder or a super T girder bridge, which is as per AS 1500.5. And second is the steel composite girder bridge for plate girders, box girders, top section girders, which is as per AS NZS 1500.6. These guides provide a step-by-step walkthrough of how Midas Civil performs design checks for these bridge types. You can access these design guides booklets through the link shared in the live chat, or we'll make sure to include a link in the comment section. Or else you can just scan this QR code displayed on the screen and claim your free copy. This link also includes detailed brochures and product information on Civil NX. Plus, we are excited to announce on our upcoming geotechnical webinar series, which is starting from tomorrow, where industry experts will share insights and showcase case studies from real projects. Be sure to check out the link, and thank you for your attention. So this is Civil NX, the new generation software for civil engineering. Thank you.
Hi. It's now your turn to get involved. Please, as always, ask our speakers questions using the YouTube chat box and who your question is directed to. Thank you also for everyone who put forward questions whilst registering for this afternoon's webinar. And we might start off with Young with this first question, asking, and it's come from Gore in the Middle East, asking you capability of Midas for stay cable and extra-dosed bridges. Thank you, Young.
Okay. To answer these questions, Midas is quite capable to handle cable bridge, be it cable stay, extra dosage, network arch, or even suspension bridge. As it was highlighted in my presentation, some iconic cable bridges like the Rusk Island Bridge in Chan Bridge was built with the help of Midas software. There are various customized features for these bridge types like the unknown load factor and cable turning take come handy when analysis for these kind of bridges types. I hope this answers your question. Thank you.
Thank you for that, Young. And then moving on to Pranav, we've had a question asking you, how is Civil NX different from Civil? Thank you.
Okay, Amanda. So we can say that Civil NX is a successor to Midas Civil. And as mentioned during the presentation, Civil NX, civil features are present in Civil NX with some cosmetic changes and UI upgrades. And yes, obviously the API integration capabilities. So as all the Midas products are developed in-house, they are all compatible with each other. But now with this product, starting with Civil NX and the API features, Midas is encouraging collaborative work and integration with other softwares. So be it other structural analysis software or our regular day-to-day tool like Excel spreadsheets. So everyone can now leverage Midas advanced capabilities using the API along with any other softwares which they are currently being used. Thank you.
Thank you. And just staying with you, Pranav, for now, we're going to move into a couple of questions around standards related. But we have had a question that said the AS 5100.5 code was upgraded recently. When can we expect the changes to be reflected in the software? Thanks.
Yes, so we are aware that the AS500 code was upgraded. I think the amendment was published around May of this year, and there are some changes in the time-dependent property, especially the creep calculation, the formulation changes, which are highlighted in the code. So yes, since this is a critical update, which should be carried out right away in the software, it is currently under development for this half, and we are expecting to be implemented it into the software within the first half of 2025. So just a note over here, along with the existing standard, like the existing calculation of the creep, the new amendment will be implemented as an addition because all the existing projects will still use or might still use the existing formulations, but the future projects might have to upgrade it or be with the latest amendment to follow the latest amendment. So yes, so it will be released probably by the first half of 2025. So not only the time dependent, but other time dependent for the AS 3600 code, and the New Zealand bridge manual version 3.4 will also be incorporated in the software within the first half of 2025.
Thank you for that. And just moving across to you, Young, we've had a question that's coming from France, asking you, Young, just wondering if there is any earthquake analysis features for bridges in Midas, and how are these used in accordance to AS 5100 and AS 1770? Thank you.
Thank you. As highlighted, Midas has implemented the AS5100 code for seismic analysis. We can choose soil site class, importance factor, and more, and the response spectrum curve will be generated, which can be used for the seismic analysis. Also, the automatic load combination feature will consider these earthquake X, Y, Z axis loads while creating the load combination along with the respective factors. Thank you.
Thank you. Thank you so much. And please keep your questions coming. Pranav, a question from Mickey. Can the Civil NX model bring it into Civil 3D for road design or vice versa? So if road alignment change, does the Civil NX model change accordingly? Thank you, Mickey, for that question.
Okay, so with Civil 3D. So yes, a Civil NX has the capability to export an IFC file and a DXF file. I think which both of these files can be imported into Civil 3D. Now, regarding the automatic change in the alignment, so it is possible if a connection can be established between the two softwares. So Civil NX has the API feature which works with a JSON format. So if Civil 3D is capable of handling a JSON input, there might be a possibility. I haven't personally used Civil 3D that much, so I'm not aware if the software is capable to use a JSON format. But yes, if it does, then we can see a possibility of automatic changing the alignment. But I believe that this question arises because of the ability to generate the BIM drawing, which is now picking up the trend of generating the BIM drawings for the infrastructure projects is now coming up. So Midas is also present in the BIM space, I'll say, and also since it is all the softwares and in-house development and it has integration with Civil NX, the product is called as Midas CIM. So for those who are interested to know more about CIM and the BIM capabilities of Midas, so everyone please drop us a mail at ausupport@midascity.com and our team will get in touch with you. Thank you.
Thank you. Thank you. And we've also got a question for you, Prav, from Mickey asking, when doing the structural analysis, how do bridge engineers manage combined load cases due to construction load and hydraulic river flow? Thank you. Thanks.
So usually to combine the load cases, there are guidelines stated wherein where the load factors as well as the combination is stated in the guidelines. So yeah, I guess we can just follow the guidelines. Appropriate factor can be assigned to respective loads, either that might be in the construction stages or after the construction stages. So just follow the guidelines and we can be assured that the structure will be safe for the combination of loads and the factors. So if you're trying to simulate that in Midas, so we have a load combination generation feature, which is automatic generation of the load combinations and the factors with any respective code, whether be it AS code or any Euro or Astro code. You can just use the automatic feature and you can get your load combination as well as the factors automatically generated in the software.
Thank you. Thank you. Ken, I have a question from Engineers Australia. So obviously we're seeing a lot of rapid, fast-paced change in this area. A, what do you have advice for our young engineers coming through? And B, what do you think are the major trends that we're going to see in the next couple of years or so?
Yeah, so for younger engineers coming through, I would definitely encourage people to keep asking questions. Find people within your organization or within the industry that you could consider a trusted advisor to be able to ask questions, to seek guidance from, and learn from. That's the biggest thing I would say to any engineer out there, is young, old, whatever, is to find your trusted advisors. Second question, in terms of trends, I think we are seeing AI coming into effect big time. So artificial intelligence and that being a tool that is available to a lot of engineers now. So, and that's rapidly coming on us. I'm learning it exponentially at the moment. But I would say with that, embrace it, get on board with it, and get on top of it to see how you can use these new methods within your design, within your task that you're doing. And also the other big thing is the real focus on sustainability, circularity, and making sure that from an engineer's point of view and the influence that we have within the industry, that we are actually making the right decisions on our projects and our designs, and just really pushing that, and not accepting the norm or how we used to do things. The world is changing. Thank you.
Thank you, Ken. And Jennifer, coming from a consultancy also, would you like to add to that?
Could you please repeat the question? I didn't hear properly.
So what we're asking is, on behalf of Engineers Australia, for our young engineers, if you have any advice you particularly would like to give them with all the change that's happening in this space, and also what do you see as the major shifts, trends coming down the pipe?
First of all, I wanted to say young engineers, they try to rely on softwares. They don't really check what the results will be. So what I would advise them, they can use the software because there are a lot of softwares coming up. They are powerful, very efficient. But if you don't put the input correctly, the results, what you expect, won't be there, or the results will be wrong. So whatever you do in the Midas or any software, check the results, something with your hand calculation, with your basic engineering fundamental. So that you won't get anything go wrong. Sometimes the engineers come, oh, this is not analyzing. So if you have not provided the correct restraint, it will not analyze, it will stop analyze. So there are basic things you have to understand. Even though the software gives you some easy way, put this or that, but unless you put them correctly, you won't get the results correctly. So you have to be very careful when you input in any software. Check one or two steps whether what you input is same as what you expect with your simple hand calculations. So that is my advice to any junior engineer. They try to use all these powerful, efficient softwares. That's my advice.
Thank you. And as I say, we've covered a lot in our fast and simple bridge modelling and analysis and design, Midas IT. So starting with you, Ken, I wondered if you could just leave our audience with, say, the main 3 to 5 key takeouts from your presentation this afternoon.
Yeah, so key takeouts for me is that, look, we do have incredibly powerful design software at hand, and you can see with Midas how Midas is opening up a number of aspects of their software to speak to other softwares, so that it gives the user choice in terms of how these softwares are interfacing with each other. So, like I said in my presentation, with the stronger analysis tools that are available to us, and with the challenges around sustainability and keeping bridges alive and functional and safe for longer, we've got analysis tools available to us now that we've never had before, and this is where, as designers, we can really push the boundaries on design and innovate, to provide better structures, safer structures, and beautiful structures. There's been some fabulous project examples that we saw in the in the Midas presentation there. You can see Jennifer's presentation was looking to really push the boundaries on Super T design, which is a standard design in Australia, but we can do things like make them continuous and make them more make them work harder for us. Get material benefits in it. So yeah, that would be my key takeaway from today.
Thank you. Great takeaways. Thanks, Ken. Young.
Yes.
Sorry, Young, what would you like to leave our audience with for your key messages, takeouts from your presentation?
Two key message of my presentation. Today we explored how Midas Civil NX delivers powerful tools to civil engineers worldwide. We highlighted the key features like the updated user interface and improved graphic and API capabilities that streamline complex processes. We also discussed the automatic modeling features and construction stage analysis and moving load optimization and detailed design report generation and many more. So all designed to boost efficiency and accurate in projects. So ultimately, Midas Civil NX is here to help Australian engineers work smarter and achieve the greater result with SA. Thank you for your attention and then listen to my presentation. This is it.
Thank you, Young. Jennifer, your 5 key takeouts, or 3.
I would say the Midas NX introduction is a really good outcome that we have been waiting for many years, although we were in discussion with Midas, because every time we start with the concept design, but the final design there will be some changes, either geometry or the section or the heights, anything change at a later stage. So this Midas NX, that API function, that will be a really useful tool. So I would say if we get that understand correctly, and if we know how to use it properly, we will be benefited for efficient design within short time, instead of starting from the scratch for every stage when they change it. Instead of that, we can use this tool API interface, and our design will be efficient in terms of time and cost. Time means cost. So Midas NX is the best presentation in this one, that I take it as a best thing, because that also explains the construction staging, everything. So the Midas NX, if anyone has an opportunity to learn, I would suggest or advise that's the best way for us to learn that right now for an efficient design for any bridge structures.
Thank you, Jennifer. Thank you. That was a great summary. And Pranav, your key takeouts.
Yes. So first of all, I completely agree with Jennifer. Every user or every engineer, first, at least at the start of his career, should do everything, should verify everything manually. That is completely on point. But because once you get your base strong, then API or API with any other software like even Python, VBA, or even Grasshopper, the possibilities are limitless. But just get your basics strong at the start, then later on you will grow at a much faster pace in your career with such advanced tools which were presented today. And I will also encourage the engineers to start using the automatic features, because I believe everyone is turning towards automation, be in any field, like in the robotics, in mechanical, even music, animations. Everyone is moving towards automation. So where we represent the infrastructure domain, we also encourage to start moving towards the automation of our everyday tasks. And yes, so we are proud that Midas can help the young engineers to stay ahead of these changes and this fast pace life with its cutting edge technology. And we are here to support engineers at every level. Thank you.
Thank you. Thank you so much. And it is all we have time for today. So please join me once again in thanking Ken, Jennifer, Pranav, and Young for their time and great presentations and advice. I'd also like to warmly thank Engineers Australia's industry partner, Midas IT, for their ongoing support. As always, if you could just take a couple of minutes to complete a short feedback form, which is linked in the description box below, to help us improve and plan for future events. Thank you again for joining us this afternoon, and I look forward to seeing you at our next Thought Leaders event. Thank you and good afternoon.